So this is Josh Cannon. He is the person standing between you and lunch. Like me, he is a maintainer of the Pants build system. As far as today's talk goes, either you're welcome or I'm sorry. Please welcome Josh Cannon.
Thank you. Before we begin, I do have 3 apologies to make. The first is for my vocal sounding. I have one of 2 excuses you're welcome to believe. The first is that I'm congested, and I've talked way too much with many of you, and had a lot of fun and got hoarse. The second is that I took the conference in a barn a little bit too seriously, and got a little bit hoarse. So, 4 apologies, one of them is these jokes. The second one was that I realized that we are an audience of physical adults, no comment on mental or emotional maturity. And so I picked a book that is a little bit higher of a comprehension level. So if you're watching this online with your toddler, or you just are a toddler, I don't recommend this. Go ahead and just put Miss Rachel on. And then the third I had was something I already forgot, so let's begin. This is story time at North Bay Python, and the book I've selected is Oh, the Methods You Can Make by Dunder Seuss. Oh, the programming does require that I do read the About the Author section. Josh Cannon, aka Dunder Seuss, has written no books so far, has been on a single podcast and done exactly 1 talk before he decided to write this book. Josh is a build engineer by day, a maintainer of the Pants build open source build system, also by day, and sometimes participates in other open source projects, Python community discussions, and conference speaking, also by day. He's a lover of getting to know enough Python to make expressive, readable, and intuitive code. He wrote this book to teach others of the power and magic that you can bring to your objects to make them expressive, readable, and intuitive. This book has been dedicated to Devin, Dottie, and Teddy with love. Congratulations! Today is your day. You will soon learn you some magic, the good and proper way. You've chosen a wise way to spend your precious time by learning from a crazy loon. Go on and rhyme about a list of methods that are nicknamed the Dunders and how you'll use them to code great wonders. They start with 2 underscores and end with 2 more, thus Dunder, which is short for double underscore. The runtime of Python calls them in many situations, allowing your objects many customizations. You'll learn all about how to emulate a container and iterators and numbers from a great explainer, comparisons, callables, and descriptors too, and how to make attributes appear out of the blue. You'll learn some new names, and I know you'll learn many, at least 1 if not 2, maybe even up to 20. By the end, you'll know magic galore. You'll be so full of magic, you'll yell, "Please, sir, no more." So with great skillful skill and lots of caffeine, let's start off with your learning with a method you've seen. Now let's pretend you're new to Python just for a minute. The first magic you will learn is Dunder init. It is almost every object's initializer, allowing you to be an attribute organizer, adding new attributes to your fresh new object, the most common magic, I truly do suspect. But where did self come from? You'll soon start to wonder. Then you'll learn it's created by just another Dunder, one that constructs the blank object to give to you, and its name you'll soon find is Dunder new. It's a special static method you'll maybe define in your class, which returns some object, then onward it's passed, to whom it turns out depend on the return object's type. If it's an instance of your class, including a possible subtype, it goes to Dunder init, you'll hear from the scholar. But otherwise, he'll say, it's back to the caller. Oh, come on. Turns out making your own book is hard. There we go. You'll see this in action, and it'll be more clear by looking for its use in the standard library. Pathlib.path uses this method to help it perform constructing an object specific to your platform. The new type, as you'll find, has defined Dunder new to return a subclass's instance specific to you. Now, with great careful care and great tactful tact, you'll see using it is a great balancing act. A magic with the power to create objects that are new is something to avoid misuse of, too. And speaking of balance, the opposite of dunder new is not oft employed. Dunder del is called right before your object is destroyed. You'll use it to release resources you've acquired, but only if you want. Its definition isn't required. But if you do write it, heed this warning as well. You must call your supers dunder del. The next set of magics involve conjuring illusions of attributes, giving your callers delusions that your object has more or less than it does. Why? Well, friendly interfaces is likely the because. First on your journey through attribute emulation, dunder get adder is the proper incantation. You'll type it out with a flick and a twist, and you'll synthesize attributes that don't exist. It's called when default attribute access fails. The attribute simply wasn't in the details. You'll get a chance to pretend it existed, and however, on your object, it isn't persisted. Now, if you wish to pretend you don't recognize this name, raise attribute error emulates that all the same. It has an alter ego named dunder get attribute, you'll see, which is called for all access unconditionally. It gets called for names both existing and not, so beware, infinite recursion is easily got. If you happen to type out self dot. So remember, when you need to access attributes inside of your thing, you won't use self dot, give your super a ring. To juxtapose get, dunder set adder is how attribute setting your classes allow. Again, by default, the attribute isn't persisted. You get to choose whether it becomes listed. This is also called for all attributes without any condition, whether it exists or not, without your permission. The last of the adder methods, you'll maybe leave off. If you define dunder del adder, people might scoff. As you'll probably guess, it's good for emulation of the removal of a name from your object's formation, and just like dunder set adder's unfortunate asymmetry, it gets called for all names unconditionally. And then you'll find out soon enough that when it comes to illusory stuff, attribute names is just where it starts. There's more you'll learn, another 2 parts. Yes, like all good things, these magic comes in 3. In more ways than 1, you'll see. The first way is the trio of names, get, set, and del. Then how they're used for other magics as well. The second in our trio of trios I'll teach to you now. These methods are so powerful, you'll see how an attribute gets to customize itself instead of sitting static on some other object's shelf. Descriptors is the name given to this technique of attributes themselves using doublespeak. First, these things work as attributes of a class. You'll see Django and SQL Alchemy use this in mass. The descriptor is the attribute, and it gets a say on how it gets gotted, setted, and deleted, per se. Dunder get is the first of these spells you'll want to perfect, conjuring values for attribute based on the owner's object, or sometimes the class, as callers sometimes will do, so your dunder get should probably support that too. In usage of descriptors, you'll find sooner not later that used for several built-in decorators. Static method, class method, and property all use this technique to customize your attributes for you. Just like dunder get adder, dunder get has 2 brothers. Dunder set and dunder delete are the others. They act just like dunder get, and proxying a call can do anything they want, both big and small. You've maybe have wondered, or even had a theory, how SQL ORMs quickly fire off a query. When you access certain attributes in the class that you set, the column descriptor is leveraging dunder get to run a SQL query using the instance's database ID and return to you the value, and maybe cache it, you see. You'll see dunder set gets called for attribute assignment. A SQL update is likely used for new value enshrinement. Lastly, dunder delete, when an attribute is told to go bye-bye, a SQL delete will likely fly by. There's one more method that plays in this game. It's a method that goes by dunder set name. Our trio is 4. Oh well, what a shame. At the end of your class definition, you see for all of the class attributes that be, if they define a dunder set name, the attribute's name, Python then will disclaim. And thus the attribute shell game now comes to a close. The illusions of attributes we have now exposed. The last trio of trios you'll learn from your trainer is emulating items inside a container. You'll see this time our trio suffixes item to quack like containers with things inside them. They are given the key, and in one case the value. Implementing container semantics is then up to you. Dunder getItem has different behaviors on the radar depending on the type of container that you are. Your sequence types, which quack like a tuple or list, will accept keys as integers or slice objects. Negative int support is something you can choose. To allow or not is simply up to you. If a value is provided outside of your bounds, an index error, your code should resound. Otherwise, if your container has a mapping background, you'll raise key error if the key isn't found. And in every case, if you reject the key's type, raising type error, you'll then want to gripe. You'll likely learn too, these rules still hold true for the other methods too. And as far as containers go, there are a few more dunders you'll want to define lest you commit several blunders. So although a trio of trios may have come to a close, you'll want to learn the other container methods, I suppose. A quick one you'll want to define is dunderlen, which helps Python define the length of your container, so when people call len, Python can return the number back to them. The second one is dunderiter, which should return an iterator over the objects that live inside of your object container. Unless it's a mapping, then what your caller sees is simply all of the mapping's keys. There's also this trivia, a bit of Python fun. If your container isn't iterable, set dunderiter to none. Now the third on our extras is named dunderContains to test if an object your container maintains. Although technically you don't have to define it, Python won't be bitter. Instead, it'll test membership first using dunderiter, going over every possible object that your object can contain and asking if any of these objects are equal or the same. But if you don't define a dunderiter method, dundergetItem is called and repeatedly tested using incrementing indexes from 0 until then it gets an index error, exception, or an equal same object, so it's probably best to define it so you'll have control of just how the object membership test will unroll. And if for optional methods you've started to thirst, another one available is dunderReversed. It returns an iterator for doing backwards iteration, but you'll only define it if you beat the default computation that Python uses, combining dundergetItem and dunderlen, indexing backwards to 0, and then there's one more optional method if you subclass dict. DunderMissing can be defined, so dundergetItem can predict what value to use if the key isn't in your mapping. Oh, if it isn't there yet. It's how collections.defaultDict or counter with care support operations on items conjured out of thin air. Python just returns to your caller the value itself, so if you want to, don't forget to store it on yourself. You'll find that you're done. You've mastered container emulation, but the next set of magics form quite the combination. See, you briefly dipped your toe into the index operator. However, you'll find the list of ops to support is so much greater. You'll think about plus and minus and start figuring that the list of operators is biggering and biggering. Let's start with just one that you can define. DunderAdd lets you support the plus sign. When your object is on the left with whatever's on the right, you return the added value, except when you might reject the operation because you don't know what to do, and instead return the not implemented singleton value. Such is the case if you don't recognize the type of whatever is the thing on the right. Oh, come on. Then, dundersub for subtraction, dundermul for times, dundertrueDiv or floordiv, depending on the kind of division you want, true or integer respectively, using 1/2 for division collectively. And speaking of operations that come in pairs, modulo arithmetic is a double dunder affair with dundermod for modulo support, and then dunderdivmod to support the divmod built in. The last of the pairs of magic method gifts is dunderl and dundershift. Sorry. The next up is dunderpow for to the power of support, whose operator is 2 asterisks side by side for short. And then, although this list was already so long, 3 more dunder methods then came along. Dunder and, zor, and or. Oh, come now, don't gripe. They're how you support ampersand, caret, and pipe. And then when your object supports the @ symbol, the method you'll want is named dundermatmul. And then, that was it. There won't be more later. 14 methods for numeric operators. Unless you think that this isn't enough, here, let's take a poll. Is there other number stuff that we need to define? Yes, raise your hand. I see. I suppose our list should expand. You'll maybe be asking yourself, oh teacher, how come? You'll ask yourself where these new methods are from. How come my methods sometimes return not implemented if to my caller a type error is presented? And so our list of methods then expands to support the same things with swapped operands, but only if the result is not implemented. And if two different types are presented, Python actually tries again, but this time with an R at the front of the name. It's not that bizarre. And calls this other method on the thing on the right. Now, let's see an example of how this works to bring it to light. Let's say someone subtracts from a list your foo. Well, list doesn't know what the heck to do, so its Dunder sub then returns not implemented. Then the runtime continues on as documented, noticing that list and foo are two different classes, and calls foo's Dunder r sub, and it passes the list object on which we've acted. So foo can say how it should be subtracted. Now remember, you'll have to be dexterous and deft, and try not to mix up a right op with a left. When in an R method, you're the one on the right. Getting this correct will make you seem bright. How about another poll? That last one was fun. Who thinks our numeric operator list is done? Oh, I got one hand. Yeah, me neither, as it turns out. And you'll see soon enough see all but one of these operators support requires three Dunders at most for each of these things. What joy to us supporting operators brings. So what sets these apart, you'll groan and you'll grunt? The last set of 13 has an I in the front. They're meant to support doing math in place, mutating the object given in the less space. For instance, plus equals uses, somehow went backwards. Plus equals uses Dunder I add, completing the addition support triad. However, these methods you can actually omit. They're there to help avoid copies a bit. If one of these methods your type is lacking, then x equals x plus y will be the fallbacking. If you kept watch, you might think I left one for later, but no, Dunder divmod has no in-place operator. Now, oh baby, oh, how the operator list will still grow, regardless of lengthy class definitions, you know. You'll complain and you'll curse and you might even swear, but you still need to learn the Dunders to compare. The names of these methods really aren't all surprising. The brevity of each name is what's really quite appetizing. Using only two letters to represent each operator, for operations, equality, lesser and greater. And exactly like the methods that I just reported, they return not implemented if the comparison isn't supported. And if you want Dunder any, you can simply omit. Dunder EQ, if defined, will be tested a bit. The return is inverted, unless not implemented. However, this time there's no quasi switcheroo. In this case, a type error is raised unto you. And in the case that the comparison is okay, a true or false as a return is the way. Or anything that's truthy or falsy is okay. It's turned into a Boolean the Pythonic way. Oh, wait. Forgive me, that's actually a new Dunder. Magics on Magics isn't Python a wonder. If you wanted to make your object seem falsy or true, you'll have to define Dunder bool too, unless perhaps you define a Dunderlen, an empty container is falsy then. The last one's on our list, and yes, it's still growing. Brevity at this point, we are simply foregoing. You'll only need 4 more, so no need to get wary to support the operators unary. Dunder neg, pause, abs, and invert you'll learn for minus, plus, abs, and tilde x in turn. And that's it, you'll think. Our list is complete. And you're right, I think. Now isn't that neat? 55-ish methods to support the operators. No list of magics in one section is greater. Actually not true, as you'll find out. Emulating a number gets to tout the longest list of required magic capitulators, because in addition to most of those operators, there's even more you'll want to support, you'll see. Numbers, I guess, just have lots of flexibility. From mathematics, the list adds on 4, Dunder, round, trunk, seal, and floor. What these methods each do, you'll notice is visible, truncating the value into an integral. Then from a number, you'll have several excursions if your object supports any of several conversions. Dunder complex, int, float, bytes, and stir are the magics with Python will look and refer to make the type conversion occur. And speaking of strings, they've got special magic too. Dunder repr and format will be waiting for you. Dunder repr returning the official string representation of an object. An executable string of your object is what your callers expect. And for Dunder format, you'll choose exactly how to trek through formatting your object based on the spec. The other magics all come in small lists, and in this tome, some of them won't exist, like the 11 methods for copying and or pickling. Yet here are some more coming for you at a trickling. If you want your object to quack like a function, Dunder call is the callable magic junction. Or maybe you'll quack perhaps like an iterator. Dunder next is the method for that imitator, returning the next value or the special terminator, which goes by the name of stop iteration. You'll raise it when there's no more values in your formation. And if you want something that supports use with, Dunder enter and exit says the word Smith. The former is issued right before the inner scope. Return self is usually the trope. The latter is called when inner scope is done, whether it is finished or ran into an exception. This method has power in multiple ways. It can release acquired resources always, but it also gets a chance to suppress an exception, return true to complete the interception. And then there are some which feels kind of wacky. Defining them sometimes feels a bit tacky. Dunder init subclass, if defining it you have dared. Every time a subclass of yours is declared, it receives that subclass as quick as molasses and was added to wean off some use of meta classes. And speaking of meta classes, there's Dunder prepare, although on second thought, you'll not want to go there. The last set of magics on this magical list of treks are the hooks into instance and subclass checks. That's right. The objects you write actually gets a say on the answer of his instance and his subclass, yay or nay. However, these are looked up on the type of your class. Ugh, meta classes. How about we pass? And actually, that's it. No more magic I'll disclose. Your journey you've journeyed now comes to a close. To know most of them, including the ones this talk doesn't entail, read docs.python.org/3/reference/datamodel.html. Or just ask Google for the URL. Since your mountain is waiting, and as you go on your way, remember the things I remembered to you today, and write all of your code the good Pythonic way. I believe Chris is here to talk to us about a snack time.
Lunchtime.
Yeah.
Let's see. I used to think the Python object model was really complicated, but thanks to Josh, I now know that it's child's play. Yeah.